One of the ways that we can represent a mathematical idea is visually. We really like these visual representations, and you do that over here. Show you the inequality, x is less than or equal to 3 on the number line. So visually we know that we've got a filled-in circle at x equals to 3, and we've got all the solutions that are less than that. Okay?
Yes.
But what about the solutions for y greater than or equal to x minus 2? Well, I can give you one solution. What about 0, 0? Would that work? So if I x is 0, y is 0, would that solution work?
No. Yeah.
Yeah? Well, 0 is greater than or equal to minus 2. That makes sense. What about 2, 2? Is 2 greater than or equal to 2 minus 2?
Yeah.
Yeah, 2 is greater than or equal to 0. That makes sense. We can see that there's a lot of different solutions that could work. How can I represent them? Right? I want to be able to find a way to represent all the solutions to this particular inequality. And we're going to look a little bit at that today. So, the first thing we think about is, okay, we know that we've got two variables here. So in order to work with two variables, we need two axes. Because here we only had one axis, because we're working with one variable. First thing is we need two axes. Let's have a look at how one of these works first, okay? So, the first thing you want to think about is just draw in this line here, x equals to 3. So mark the point where x equals to 3. That's this guy here. And we know we've got a solid line because we've got less than or equal to, so it's including that value. And you want to think about, okay, where are the values where x is less than or equal to 3? Well, I know this guy here is 4. This guy here is 2. So all the values where x is less than or equal to 3 would just be everything on this side. And everything on this side, how do I represent that? Well, the regions in the Cartesian plane is going to help us understand that. We're actually shading this whole side here. Can you see that this line, right, we know it's going to go on forever, so we create these regions, okay? And so all the values where x is less than or equal to 3, that's going to be the region that we have. Similarly for this one, y is greater than minus 1. Well, I want to think about where is the line y equals to minus 1? Well, I can mark in the point there. There's minus 1, there's minus 2, that's 0. Now in this case, we don't have that line being equal, right? We're not including that line. So if I mark it in, I don't want to include it, so I put in a dotted line. So that's the line y is equal to minus 1. X equals to 3 there. Okay. And I'm thinking, okay, all the values where y is greater than minus 1. Well, obviously all the values that are greater are going to be up in this case. So we shade in this region here. Now here comes the slightly trickier bit. Let's look at something like this. Let's look at the one that we had before, up here. So we already know some of the solutions that will work for that particular inequality, but how do we represent that on the Cartesian plane? Well, we want to start with the same thing. We want to draw our Cartesian plane. And we want to draw this line, y equals to x minus 2. Okay, I think, okay, I've got a y-intercept of negative 2, and I've got a positive gradient. So if I read it from left to right, it's going to be going, which way? Up, right? So if I've got a positive gradient, it's going to be going up. Okay. And this is my line here. So remember, if we have an equal to, less than or equal to, then we have a solid line going straight through. Now, can you see that we've created two regions now, right? Because this line is going on forever. I've got this side and this side. How do I work out where my solutions are, where I'm going to shade it? Well, here's where we want to test a point. Okay? So we can test any point. One that we commonly test is 0, 0. Because that's really easy to substitute in. 0, 0 is the origin here. Okay, so let's see what happens when we substitute in 0, 0 into this inequality. Okay, so test 0, 0. We've got 0 greater than or equal to 0 minus 2. 0 is greater than or equal to minus 2. Is this true? Is 0 greater than or equal to minus 2?
Yes.
Yeah. Okay, so we know that this point here is in the region where we want it, right? We can test another point. Let's just test another point just to make sure. Let's test 1, 1. Let's test 1, 1. Does 1 work? Can you try that for me?
Yeah, it works.
It works?
Are you
Okay.
sure?
What are we actually testing here? So this works. 1, that'd be
What
up
size?
here. What we're saying is, what are the solutions for x and y that actually meet this inequality, where y is greater than or equal to x minus 2? Where are all the solutions for that? And it turns out, all the solutions are on this side of your line. Because once you've tested 0, 0, you know that all your solutions are going to be on this side of your line. And that's the regions in the Cartesian plane that we created. So, first thing you want to always do, you want to be graphing your line first, okay? Is this one where it's going to be dotted or solid? Dotted, right? Because we don't have that equal to value, okay? So, I want to be sketching this line here. Y equals to 2x minus 6. And again, I want to start by my y-intercept, that's really easy, it's going to be -6. And my gradient, that's going to be 2, okay? And that's a positive number. And if you work that out, if you find the intercepts, you'll realize that you've got an x-intercept of 3. And so let's just construct our line. You want to be testing your points, so let's test 0, 0 again. Testing 0, 0, what do we get?
-6.
-6, is that true or false?
False.
Right, okay. So we know that the origin, this point here, doesn't lie in our region, right? If that doesn't work, then we know it's going to be on the other side, right? Exactly. So I'm not going to shade in this side this time. I want to shade in everything on this side over here. Okay? You don't have to shade it in clearly, just make sure it's clear somehow, right? You don't have to shade it in the whole thing, just make sure it's clear what you're shading.